So thank you very much to the organizers of the Biosecurity Symposium for having me join you all here today. I'm really looking forward to the entire workshop, and I think that there's a lot that everybody has to offer here. So I'm going to start by saying that it's time our way of thinking about the relationship between biology, research, and society needs to change. You're all here today because you understand that one aspect of that relationship, biosecurity, is in flux, and you're trying to get a better understanding of what that means and why that matters. So over the course of the symposium, you'll have many opportunities to explore these questions. My role in opening the discussion is to give you a sense of the reasons why this work is important and to seed in your minds ideas about how to approach it. The biggest idea I'd like to leave you with is this. It's important to start thinking of the work that we do to understand and govern biosecurity as itself a site of experimentation. I think many of us, particularly those of us who see our role as having to ensure biological research and bioengineering proceed safely and securely, are hunting for answers to basic questions in this space, like what is biosecurity? Is this piece of research a threat? What should I do to ensure biosecurity? We should see any answers to these questions as contingent and open to investigation. Over the next half hour or so, I'm going to talk us through how an experimental approach to biosecurity governance can help us work through these questions. Our journey is two main stages. First, I'll go over why experimentation is a useful way of thinking about governance. In doing so, I'll showcase a few efforts, several of which you'll hear more about over the next 2 days, where this experimental mindset is already at work. I'll then turn to thoughts about what needs to change in our current ways of engaging with and overseeing biosecurity so that we can be more supported as we build our own next experiments. So let's turn to what makes us interested in biosecurity at all. There are lots of reasons you might give. Maybe you see biosecurity as one of the primary sources of existential threat to our civilization should a harmful biological entity intentionally or unintentionally be spread around the world. On the other hand, on the other end of the spectrum, maybe you're required to implement biosecurity protocols dictated from on high that have to be shoehorned into a system that was originally set up to deal with biosafety or other issues, but not biosecurity. The point at the start, though, is that people in the biosecurity community are often placed into one of two rather unhelpful buckets. Those curious about what it is and whether we have it and how to keep it, and those who see biosecurity as just another compliance burden to be managed in the process of research. And these buckets of curiosity and compliance are actually pretty unhelpful because, well, for one, they shouldn't be seen as buckets. The process of biosecurity governance is as much of an art as it is a science. Standards and routines are still unsettled. The policies and regulations that we do have need to be revisited in light of new advances in the life sciences and changing understandings of the relationship between biological research, innovation, and society. So how then do we combine compliance and curiosity mindsets? Well, for those of you with kids, an analogy is close at hand. I have a 7-year-old and a 4-year-old. I try to be reasonable in setting and enforcing rules around the house, but I also want the kids to know that these rules are constructed, not edicts from on high, and to give them paths to question them if they think that they're unfair. So when a new rule needs to be created, I try to bring them into the process, explaining why we need the rule and asking if the rule that I propose is reasonable to them. When we try it out and it doesn't seem to be getting the results that we desire, then we can revisit it. There are several things going on here that I want to bring out. First, I'm trying to see my kids not only as, not as unruly youngsters to be disciplined, but as reasonable humans who see the world differently than I do, but still need to live in it with me. Second, my wife and I both know that rules overlap, and one incentive might just exacerbate another problem, so we try to keep an eye out for how new rules interact with our existing system of household governance. And third, rules change. By giving the kids the knowledge and the opportunity to question a rule and suggest a better alternative, we're trying to make them partners in the family, not minions. Now, of course, this goes comically wrong at times, and other times the law does get laid down from on high. But we try to make the ideas of cooperation and joint governance the default rather than the exception. And this is the point at the root of an experimental approach to biosecurity governance. Security is only one of very many goals that our research can be directed towards. Our default understanding of the governance system should be that we're working with people who are generally reasonable, who see the world differently than we do, and who will likely have innovative ideas on how to improve the system if they have a pathway to be heard and responded to. The job of people designing biosecurity governance is less about determining objectively what is a threat and what should be done about it, and more about creating a system of feedback loops to continually assess in what ways policies have intended and unintended effects, and how they can be iterated upon to improve both security and the many other goals being balanced in our innovation system. Well, these points came out clearly in a workshop that we ran back in 2019 at the University of Cambridge, when workshops were in person, if anybody can remember that back that far. We gathered a cross-section of the biosecurity community, from lab academics to biosafety officers to high-level government officials, to work out what benefits might come from thinking about biosecurity governance as itself an experiment. There were several dozen people there, and over the course of the 2 days, we had a chance to really work through a lot of these questions. This led to a policy forum piece in the journal Science last year that made several points about why an experimental approach to biosecurity governance could actually be helpful. First of these points is that we need to be thinking outside of the box of a traditional security mindset. And at this biosecurity symposium here, panels like Session 5 on biosecurity governance beyond laws and regulations are opportunities to do just that. By thinking of governance as an experiment, we're encouraging ourselves to unpack the assumptions that are being made about biology, society, and security in the construction of that experiment. One example here can come from the Department of Commerce, which maintains the portion of the export control system for the United States that covers the so-called dual-use goods and technologies. They were recently charged a couple of years ago by Congress to establish a standing advisory committee on emerging technology. As part of that charge, they're supposed to imagine possible future innovation pathways that might lead to the creation of new security concerns. While this committee, called the Emerging Technology Technical Advisory Committee, can spend its time simply finding those very occasional areas of innovation that are conducive to the limited vision of export controls, I've argued that they should instead see their work as an opportunity to document why export controls aren't a good idea for so many areas of research, particularly in biology, and then be the instigator of a broader conversation around what possible alternatives there are and how export controls fit alongside of them. To date, this committee doesn't seem to be taking this approach, and instead is focusing on keeping the ship of export controls in its lane. This is a lost opportunity for creating a new space for experimentation in security governance generally, as well as biosecurity governance more specifically. Now, a different example of an experiment enabling an alternative method of governing is the work of the FBI's Biological Countermeasures Unit. This group, through some ingenuity of those involved in it, was able to convince the higher-ups of the FBI to let them try a very kind of non-FBI approach to how to think about the way that the FBI should be concerned about security concerns in biology. And what they did is they rethought the relationship between biology, security, and the different actors involved, from lab bench researchers through to members of the government and many others. This unit was given the space to approach biosecurity as a community responsibility, rather than as the sole domain of intelligence or military units. This is an approach that Ed Yu, who you can see here on the big screen, likes to call safeguarding science. And it leads to some kind of counterintuitive actions that this unit takes, like just going and hanging out in DIY labs, or giving presentations to thousands of iGEM students at the annual jamboree that they hold, which you can see here from a few years ago. When given this space to experiment, therefore, we can test out how these different sets of assumptions go from theory to practice. And that leads me to the second reason that an experimental mindset is helpful. Thinking of biosecurity governance as an experiment requires us to measure how our systems in practice are related to our ideas of how they should work in principle. Session 3 on biosecurity successes, challenges, and lessons learned will be an example of this type of feedback loop at work, a specific instance of it at work. But what would it look like to make this looping more systematic? One example of where this is happening is the BSL-4 ZNet, the Biosafety Laboratory Level 4 Zoonotic Network. Started in 2016, it brings together 11 high-consequence animal health and public health laboratories from Australia, Canada, Germany, the UK, and the US to strengthen partnerships between individual labs and build an integrated capacity to respond to high-consequence biothreats. And so this network is a place to build on practices from other groups, to give feedback on how those practices are porting over between labs or not, some lessons learned that can then be shared collectively with the group and built upon there. But it's just between these 11 labs, or at least last I checked, there were 11 labs in it, and just on these very high consequence BSL-4 type research experiments. But a lot of the emerging security concerns that we might be wanting to pay attention to, there's every likelihood that those would come from BSL-2 labs, right? From workbenches that are in places that have much less training in a lot of the safety and security protocols, and the security protocols in particular, that an institution like a BSL-4 lab would have. And another great example of this experimental process at work is iGEM's Safety and Security Program. iGEM, the International Genetically Engineered Machines Competition, has been going on for a long time now, and Tessa Alexanian will say a lot more about this tomorrow, so I don't want to steal her thunder here. But I'll just state very briefly that the Safety and Security Program has a yearly review, systematic kind of review every year of what's working in the program and what isn't, where they reflect on the assumptions that they're making about, well, what can the students do, what can we reasonably expect of the students in terms of their laboratory setups, in terms of their training, and in terms of the time that they have to attend to all of the aspects of their project, let alone the safety and security concerns. And in reflecting on this, they're able to make changes to the entire structure of the safety and security program, however they see fit. This allows them to test on a yearly basis the incentive structures for students to report and to innovate on the safety and security aspects of their work. And they can do this because of the framework of iGEM as this global competition that is apart from but still situated within and in relation to the institutions of the specific teams from the 300 some odd teams and that come to and compete in iGEM each year. So a third way to understand the importance of an experimental mindset is that it reminds us that improvements come from sharing what works and what doesn't work. We need to be better at collecting and sharing data about what is and isn't working in these governance experiments. Who here, for example, knows how many biological research institutions in the US run their institutional review entities responsible for overseeing potential dual-use research of concern through their institutional biosafety committee as opposed to being a separate entity? Who, for example, limits their DIRC review to just the 7 experiments of concern on one or more of the 19 agents listed in the institutional DIRC policy? And who goes beyond that? The fact that this kind of data is hard to come by shows the lack of data about basic aspects of biosecurity governance right now. But we need much more data than this if we're going to be serious about thinking about biosecurity governance as itself an experiment. One of the trickiest types of data, and the one that we weren't able to get very far on at our 2019 Cambridge workshop, was about failures and near misses. There are all kinds of reasons, from institutional culture to avoiding liability to maintaining proprietary data, that discourage sharing within biosecurity governance community on examples of when, for example, research that probably should have been subject to further review and revision was not caught. This will be a topic of a breakout group in the next session. To share information, though, we first have to generate it. What kinds of thinking about potential security issues, for example, goes on at the funding stage of research as opposed to the conduct or the publication stage? What if we could follow that thinking through the life cycle of a research project? One idea on how to do this is to create a kind of ledger system for biosecurity oversight that would follow research from funding through publication. This idea is being explored in the Visibility Initiative for Responsible Science that you can see here on this slide, which is being led by Megan Palmer at Stanford, and I'm involved in this effort, as are several others that you can see there. So this is a chance to experiment with saying, how do you create an ability to just see what kinds of biological security thinking is going on at these different stages? Now, if we think of all of these aspects of why it's helpful to have an experimental mindset, we might want to think about why or how we could have a kind of orchestrating entity for these various experiments that are going on. My mind, at least, turns to an entity like the National Science Advisory Board for Biosecurity. But there are problems with thinking of the NSABB in this kind of way. The NSABB was established in 2005 after a recommendation for its creation in the National Research Council report, Biotechnology Research in an Age of Terrorism, often known as the Fink report after its chairman. So the NSABB was meant to be a place for these conversations about alternative visions to be discussed, right? It was meant to be a place to support feedback loops between design and practice. And it was supposed to be a place where we could share best practices in biosecurity governance and on how to measure effectiveness. But the NSABB also has this very difficult relationship with the NIH and other aspects of the biosecurity community. And it sits within NIH, even though we understood, in setting it up, I wasn't part of that, but in setting it up, it was understood that situating it within NIH would be problematic. After the H5N1 influenza case in 2011, the board basically went dormant, and when its members' terms expired, they were replaced, and the new board convened to discuss gain-of-function work. That board expired, and the NSABB went dormant again for several years, only reconvening in January of 2020, which was just shortly before its work once again got put on hold, somewhat paradoxically, by the pandemic. I'm looking forward here to discussing how to re-enliven a space like the NSABB for building and reflecting on biosecurity governance experiments. And it leads me to the second part of my talk, which is on why institutional reform is needed to support an experimental mindset. All of these examples of experiments are great, but they're happening in pockets, more or less, here and there around the US and the world. Making this mindset more systematic and pervasive is going to require institutional reforms. One of the biggest reforms that needs to happen is a change in how we understand the relationship between science, society, and security. A simple way of putting this is that research is often seen as being done apart from society, rather than being seen as a part of it. And having this kind of mindset leads us to down a particular path. Thinking of science as being apart from society leads us to think that science is about producing objective truth, that is true everywhere, in all places at all times, and not as being more situated. This, in turn, leads us to think that knowledge benefits society, that we do research in the lab, that it goes out into the world, and then there is a benefit that accrues. And when that doesn't happen, those rare cases are knowable in advance. The idea of having research be apart from society also helps us to think of the state as being the best entity that can construct or identify and govern security concerns. This is something that is the job and role of the state, not of the researchers in their lab. And thinking through that process then can lead to a sense of it being natural then for academia to be self-governed instead of being seen as a part of the broader workings of society. Well, what if we were to think of instead as research as being a part of society? So in this kind of context, we very quickly come to understand how the decision about benefits and harms are always contested and subjective, that one group's idea of what is a good might be another group's idea of what is a bad. And when we realize that, and that research will impact different types of communities in different ways, then it opens up to our minds an idea that how we constitute what should be a security concern should actually be a subject of debate and analysis. So we shouldn't just immediately understand things as being concerning or not concerning, or have that be something that is done by a group of people in a closed room somewhere over there, but not over here. Instead, the decision framework through which we decide what counts as a security concern should be something that we debate and discuss. A classic example of the view that science is apart from society is the way that security got sidelined at the Asilomar meeting in 1975. Now, many, if not most of you, know about the Asilomar gathering of molecular biologists and a few others in California. But for those of you who don't, This group came together in the early days of genetic engineering to work out how to govern their field. The goal here was to see the treatment of genetic engineering as primarily a technical issue, to be assessed and controlled primarily by those who were close to the field under the auspices of the National Institutes of Health and who was the primary funding agency for biomedical research at that time as well as now in the United States. It's important to remember here that there's really no knowledge at this time of what the potential impacts of biology and genetic engineering were going to be. There were lots of future applications that were envisaged, but not really much time or energy was given to envisaging future risks. There was a concerted effort to avoid the public, in particular the peace environmental aspects, who were seen as potentially tampering with the science. And there was also, though, a need to be seen to be sympathetic to the concerns of those types of publics, because it was their tax dollars in the end that were paying for the majority of this research. And so the people at Asilomar, the organizers, were pursuing an agenda, that of persuading the American public that genetic engineering was under control, that the scientists responsible for developing the technology knew what they were doing, and that responsibility for the future development of the field was best left in their hands. So who was there? Well, molecular biologists, a handful of reporters, and a couple of lawyers, basically. Who was missing? Well, there were molecular biologists who were out of the mainstream and out of predominantly the North American context, who might be wanting to raise more of these societal concerns. NGOs, evolutionary and ecological genetics people, who might be looking at the broader environmental effects, but also, of course, social scientists, ethicists, trade unionists, public interest groups. None of these people were represented. And if we were to think about what was off of the agenda in this meeting, Susan Wright has noted in her seminal work on the early days of genetic engineering that David Baltimore got up at the beginning of the meeting and laid out what they were going to talk about and not talk about. And importantly, he said that a couple of things were off the agenda. Environmental concerns were off the agenda. Human genetic engineering off the agenda. And then he said an issue which I think is very serious and which many of us have cared about for a long time, which is the potentiality to utilize this technology for biological warfare. And again, although I think it's obvious that this technology is possibly the most potent technology for biological warfare, this meeting is not designed to deal with that question. And this kind of sidelining is very important for then what gets talked about at the meeting and what happens after it. So what was on the agenda? Questions about safety, about the need for the public to be persuaded that scientists were responsible and acting responsibly. The solution that they wanted to come up with needed to seem natural, i.e. that science creates safe organisms and containment facilities. And the values and the interests of Asilomar were needed to be seen as also the values and interests of the society. There needed to be the organizers were very aware of the need for the scientists to be seen to be sacrificing their work in some way, to be slowing it down or otherwise altering it in order for their this perception of responsibility to come about. And that then gets crafted into the outputs of Asilomar. When we think of today how we understand the safety and security concerns in biology, a lot of what came out of Asilomar was the structure of our understanding today. So the biosafety level system, like the idea of having different levels for biosafety in the laboratory environment, was something that really came from the Asilomar meetings. The Recombinant Advisory Committee, this national committee that was set to review experiments, and its current successor, the NextTrack. The development of a model organism of K12 E. coli as a way of creating an attenuated strain that can work in the lab and then can be a source of biological research. All of these things were outcomes of this Asilomar meeting, which in turn was grounded in this assumption of biology being apart from society. How does this mindset hurt us today? Well, for one, it rewards researchers and their institutions much more for compliance than for curiosity in any form of governance, let alone in security governance. All of these forms of governance are seen as being tacked on, added on to the research process, a burden for research, something that is a hoop that has to be jumped through. And another way that this hurts us today is that security is often recast as a safety issue to be acted on in the labs. So in order to get security talked about, for instance, dual use of research of concern, the institutional review entity for that often becomes the Institutional Biosafety Committee. And this, again, why is there an Institutional Biosafety Committee? Well, it's because of these discussions that had their grounding in Asilomar. And those discussions were explicitly to say we're not focusing on security. And now we're taking that entity, the Biosafety Committee that has come out of that kind of thinking, and saying, hey, you have to look at security now. But it purposely was designed not just not to look at security, but to not see security as an issue for it to be addressing. And then third reason how a Asilomar mindset hurts us today is that scientists think of their networks of where they turn to generate new thinking and new ideas and new paths forward for the research. Those often don't include security people. These can be intelligence personnel, but they can also be the institutional contact for dual use research, or they can be social scientists like me and others who are focused on the ways that security and science and society are interconnected with each other. They're not seeing these people as places to go to and people to talk with and generating new research pathways. So what would it mean to reimagine a concept that's really pervasive in our field right now, like the concept of dual use, as a feature of all biology? I'm happy to go more into the history of dual use as a concept in the question and answer period, although I hope also that Penn Perman might get into this a bit in the next session when he talks about the history of biosecurity. But here I'll basically note that when dual use became a term more commonly used in biology in the early 2000s, there were at least two paths that we could have taken in this. So one, if we start thinking, oh my gosh, any biology can be a security concern, how do we think about this? One path could be to say we only need to focus on the areas that are most concerning. And so then we immediately start thinking, well, what are the areas that are most concerning? What do we turn to? Well, let's first look at the select agent list and maybe then cull that list down a little bit and just focus at a subset of them. And then of those select agents, let's just think about experiments of concern. And so if you're doing an experiment concern on a select agent with federal funding, then we have this huge apparatus to think about security. But if you're not doing it, we really don't have much to think about, much institutional support to be thinking about and thinking about the security concerns in technology and in research. What if instead of starting down that line, we started down a different line where we thought, oh yes, anything can be a concern. That's right. That means everybody needs to be able to understand when an area of research might be becoming more concerning. So what we need actually are methods to understand when things might be a concern, not a list of things that are potentially concerning. This then leads us to a very different structure of the biological research system that focuses on networks of expertise that are about, connecting up people with security expertise with those with other forms of expertise, and a flexible typology and what constitutes a security concern. Okay, we can have general agreement that select agents are things that need to be looked after, but We need a flexible typology in order to capture all of the new ways that we might be wanting to be concerned about cyber biosecurity, about novel genetic technologies like gene drives and others. So where does that leave us? What do we need to be able to experiment in biosecurity governance? At least three things here. We need to lower the stakes to learn from our governance attempts. We need to develop an incentive and reward system for experimenting in biosecurity governance. And we need to reform in the training that we send our biologists and those who are going to be interacting with them, the computer scientists and others. We need to reform that training system from the undergraduate level on up to focus on biology as a part of society rather than being apart from. Thank you very much for listening to me today. And on a personal note, it is a real pleasure to be part of this community. There are a lot of us who want to see change in biosecurity, even with the burden of the history of the way that we think about it. And I hope that the idea of experimenting in biosecurity governance can help us unstick our existing ways of governing and can build momentum for exploring a future in which biosecurity is a natural part of the research cycle. So thank you very much.